With multiplication properties of exponents. Two objectives this lesson: we're going to multiply monomials using properties of exponents, and we're going to simplify expressions using the multiplication properties of exponents. First thing we need to learn is what in the world is a monomial? A monomial is a number, a variable, or a product of a number and one or more variables with whole number exponents. What's a whole number?
Not a fraction.
Not a decimal, not a fraction. It's like the counting numbers, right? 1, 2, 3, 4, 5. Okay? So the only exponents that we're going to work with in this lesson are going to be whole number exponents. So we're going to create a list of examples of monomials. Okay? So based on this definition, a number. Okay? That's a number. That's a monomial. All right. A variable. There we go. That's a monomial. A product of a number and a variable. 7y. That would be a monomial. Can have more than one variable. So 3xy would be a monomial. And it's got to have whole number exponents. So we could do x squared, or y to the fourth, or z to the 10th, or 7xy to the third, or 8 to the second, y to the third, z to the fifth. Those are all monomials, okay? By the way, it says it has to have a whole number exponent, right? What about those first couple that I wrote where I don't see an exponent?
It's 1.
The exponent is 1. That's correct. Even though you don't see it there, the exponent for all of these terms is 1. So 7 to the first, y to the first. Okay? 7 to the first, x to the first, y to the third. So if you don't see an exponent, there's still an exponent there. It's just we don't need to write it. Kind of like all of these numbers are positive, right? I don't have to write a plus sign in front of them to show that they're positive. Can I have a negative monomial? Can I have negative 4x to the third? Is that okay? Yeah, that's still a monomial, even though it's negative. Okay, so we good?
Yeah.
You have learned a new vocabulary term already, one slide into the lesson. So let's do this. Let's circle the ones that are monomials. How about 10?
Mm-hmm.
Yes, it is. How about x plus 13?
No.
Why not?
Because it has a plus.
Because it has addition in it. If you look at the definition, it can't have addition in it. It's got to have only multiplication going on. So this one is not a monomial. H squared.
Yes.
Yes. M.
Yes.
Okay. 5nm.
Yes.
23 ABCD to the 23rd.
Yes.
Yes, that's a monomial. XYZ squared over 2.
No.
No.
What about doing this? XYZ squared, and we multiply it by a half. But it's being multiplied. It's a product.
Yeah.
This actually is a monomial. Okay? How about xy over z? That is not a monomial. Cannot have a variable in the denominator. Okay? If it's only got constants in the denominator, it's still a monomial. If it's got variables in the denominator, it is no longer a monomial. Okay? All right. So that's the difference between the two. This one has a constant, this one has a variable, this one doesn't work as a monomial. Okay? Here are a couple more little, I guess, vocabulary type things. This together, 3 to the 4th, would be called a power. A power is made up of a base and an exponent. And what the exponent tells us is how many times we're going to use the base as a factor. So 3 to the fourth really means 3 times 3 times 3 times 3, right? You guys know this already. And then if you multiply it out, it's 81. So we want to expand each power and find the product. So 5 to the fourth would look like what? 5 times 5 times 5 times 5. And what does that equal? 625. 8 to the fifth is?
8 times 8 times 8 times 8 times 8.
We want to use 8 as a factor 5 times, and it equals, anybody?
Two, seven, six, eight.
32,768?
Yeah.
Okay. All right, now let's talk about going the other direction, right? The following products using exponents. So what is this one going to be? 3 to the 7th. 9 to the 5th. 4 to the 2nd. Okay? All right, you guys are pretty comfortable with all that, it seems like. Now let's think about this. If we have 2 to the 3rd times 2 to the 4th, the way it would look is like this. It would look like 2 times 2 times 2 is 2 to the 3rd, correct? And then we're multiplying by 2 to the 4th, which is 2 times 2 times 2 times 2. And that comes out to be 2 to the 7th. Okay? So rule 1, when multiplying bases, add exponents. Okay? So we want to do 2 times 2, and we're going to add 3 plus 4 is 7. So we want to simplify these. 3 to the 3rd times 3 to the 11th would be?
3 to the 14th.
3 to the 14th. Notice that I keep the base the same. I did not multiply 3 times 3 to get 9 and do 9 to the 14th. I did 3 to the 14th, okay? 4 to the 2nd times 4 to the 5th times 4.
4 to the 8th.
2 plus 5 is 7. And even though we don't see it, there's a 1 there, right? So 2 plus 5 is 7. 7 plus 1 is 8. 4 to the 8th. Okay? Let's simplify each of these expressions. This would be, this one right off the bat, I'm going to throw a curve at you here. What are the exponents for the 6 and the 2?
1.
1. So can I just multiply? Well, they're not the same base. You can't do, what would you add? I have a 6 times 2.
12.
I can multiply those because no exponents are involved. So I can just do 12 and n to the 3rd times n to the 7th.
11.
So it would be n to the
11.
11th,
Wait,
10th. 12 n to the 10th. Everybody understand why I can multiply the 6 and the 2? No exponents are involved, so it's just multiplication. If we wrote this out, it would be 6 times n times n times n. That's 6 times n to the 3rd, right? And then it would be times 2 times n times n times n times n times n times n times n. 1, 2, 3, 4, 5, 6, 7. Okay, now, these two are the same thing, right? Now, commutative property of multiplication lets me do what?
Multiply 6 and 2.
Multiply anything in any order that I want to. So I can do 6 times 2 to get 12, and then I've got 10 factors of n, so it's n to the 10th. Okay? How about this one? 3y to the 4th times 7y to the 5th. 21y to the 9th. And if we wrote it out, it'd be just like this one. You have a 3 times y 4 times times 7 times y 5 times, and we can rearrange those to get 21, y to the 9th, right? All right. Negative 4rx squared t to the 3rd times negative 6r to the 5th x to the 2nd t. That's getting a bit ridiculous, but let's do it.
24.
Negative 4 times negative 6 is positive 24.
R.
R to the 6th, because there's a 1 plus 5 to get 6, good.
4.
X to the
4.
2 plus 2 is 4.
T to the 4.
T to the 3 plus 1 is 4. Okay, 24, r to the 6th, x to the 4th, t to the 4th. All right. What about this? Consider 3 squared to the 4th power. And so what this 4 here tells me is that I need to do 3 squared 4 times, right? So what this would look like is 3 squared times 3 squared times 3 squared times 3 squared. That's 3 squared to the 4th, right? And then 3 squared looks like 3 times 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 3. So what does that end up being?
3.
That ends up being 3 to the 8th. So as that example shows us, when an exponent has an exponent, multiply them. So this exponent in the parentheses gets its own exponent, and we have to multiply. So 2 times 4 is 8, right? All right, so 5 to the 4th to the 5th would be 5 to the 20th. 15 to the 3rd to the 9th would be 15 to the 27th. All right, that's a big, super huge number, by the way, but that's all right. All right, let's try some more examples here. Ooh, 2 to the 3rd to the 2nd to the 4th.
It would be 2 and 24.
Okay, just multiply the exponents. 3 times 2 is 6. 6 times 4 is 24. 2 to the 24th.
T3W3.
Ooh, I like it. I thought I'd trip you up with this one. T to the 3rd, W to the 3rd. That make sense?
Yeah.
Because the T has a 1 exponent, so it gets multiplied by 3, and the W has a 1 exponent, it gets multiplied by 3. So T to the 3rd, W to the 3rd. Good. All right?
2 to the 3rd, Y to the 3rd, and
2 to the 3rd, Y to the 3rd, Z to the 6th. 2 times 3 is 6. Good. I thought I'd trip you up with some of those. All right, here's how this is going to look in some of your exercises today. Write the area of the square as a monomial. How do you find the area of a square?
2x. Height times width.
Length times width, okay? Length times width. So you would take 2x squared and then square it, right? So we would write it as a monomial, 2 squared x to the 4th, okay? What is 2 squared?
4.
4x to the 4th. Okay?
So do you want us to simplify like that?
Yeah, especially if it's just like a small number squared. I mean, if it was like 2 to the 403rd, you can't simplify that really. So,
Fish?
yes,
I need test Oscar for dismissal.
she's on her way.
Thank you.
All right, express the area of a triangle with height 4a and base 5ab squared as a monomial. So what is the formula for the area of a triangle, by the way?
Times width divided by 2?
1/2 base times height, right? So, or base times height divided by 2 is fine. So we would take 1/2 times the base, which is
Uh,
5ab squared, times the height, which is 4a. Now I can multiply in any order, right? So 1/2 times 4a is pretty simple. What's 1/2 times 4a? So that would be 5ab squared times 2a. 5 times 2 is 10. A times a,
2 with A.
a squared, add the exponents. It's a to the first times a to the first, so it's a to the second. And then b squared, right?
Yeah.
10a squared b squared. All right, our last one is going to look like this. Simplify monomial expressions. This kind of gives you a checklist here of things you need to do when you simplify monomial expressions. First, each variable base appears exactly once. What that means is we don't want 3 x's in our final answer. We don't want 2 y's. We want the letters to show up only one time. There are no powers of powers. What that means is we don't want any parentheses. Okay? And then all fractions are in simplest form. That's a no-brainer. You should always put fractions in simplest form no matter what. So we're going to simplify this. 3xy to the fourth all to the second power times negative 2y to the second to the third. Order of operations tells us to start with what? Parentheses. So we're going to run parentheses first. I've got an interior set of parentheses here. So this would be 3, and we can run separate sets of parentheses at the same time, right? So I can do this set of parentheses while I'm doing this inside set of parentheses. So 3xy to the fourth to the second becomes 3 to the second, x to the second, y to the 8th, times, we're going to have negative 2 to the,
6.
well, I'm just doing this inside set.
Oh, well,
Negative 2 to the
2.
second,
Y to
y to the second, and all of that to the third, right? Okay. One step at a time here. So 3 squared x squared y to the 8th times negative 2 to the 6th y to the 6th. Okay? All right, now what? Now we've got 2 y's here. I don't want more than 1 y, right?
Yeah.
Okay. So I would need to get, I like to go in size order here. Negative 2 to the, whoops, I wrote that wrong. Negative 2 to the 6th. Negative 2 to the 6th times 3 to the 2nd times x to the 2nd times y to the 14th. Add the exponents.
Would you not simplify negative 2 in here?
Well, you'd have to do negative 2 to the 6th. We could, and you can use your calculators. Negative 2 to the 6th, that'd be 2, 4, 8, 16, 32, 64, right? So it'd be 64
Yeah.
times 3 squared is 9, x squared y to the 14th. And then you just have to do 64 times 9.
Is 576.
576 x squared y to the 14th. Really, I'd be okay with you leaving it like this.
Is this supposed to be negative?
No, because
It's got an even, if it's got an even exponent, it will be positive. If it's got a negative, odd exponent, it will be negative. Because, think about it, if you have -2 to the first, that's negative, right? -2 to the second would be -2 times -2, so that's gonna be a +4.
So odds are.
-2 to the third would be +4 times -2, so that'd be -8. And so, yeah, if it's got an even exponent, an odd number will come out of even. If it's got an odd exponent, a negative number will come out negative. Okay, that make sense? All right,
Wait, odds are negative.
odds, if the base starts out negative, odd exponents are negative. If the base starts out negative, even exponents are positive.
So odds are
Yeah.
negative.
All right,